Hello, this is Professor Dan Kernler of Elgin Community College, and you have made it to the last video in my statistics series. In this one, we talk about comparing multiple means. Let's get to it. All right, so first, congratulations making it this far. This has been a long series. I hope you've enjoyed it. I know this has been it's really been fun for me. I've done a lot of work. It's been a ton of work at editing and researching and all this, but I've learned a lot. I've learned a lot of interesting facts looking at some of the data that we've looked at, and I hope you found it interesting as well. Now, we've looked at means before. We looked at the average number of children in the family for, in our database, the children of immigrants, and we compared that to the general population. We also compared the mean age that lesbian, gay, bisexual individuals realized their orientation. We compared men versus women. So we compared two populations. What we're going to do now is we're going to compare more than two means. I have up here a box plot comparing the current life rating, that's a 0 through 10 rating, by whether or not the individual has ever attempted suicide. So we have those who have yes more than once, yes just once, and no. So there are three different groups, and we haven't learned about how to compare three different groups before. And that's what this section is about. The official title is One-Way Analysis of Variance. It's a little confusing here. We're not actually, we're using the variance, but we're not actually comparing the variance. We're comparing the means. It's called one-way in this case because we just have one factor. So we're going to look at different groups. We're going to look at one factor. I'm going to use some theoretical examples to help explain how this works. Suppose I have some exam scores, and I've got case one here, three different classes, and these box plots demonstrate their distribution of exam scores. And then here's case two, again, three different classes. Now, if you look closely, their means, or their medians, I should say, are actually the same. However, the classes in case one appear to have more variance. They appear to be more spread out. And so it's hard to know, are they really different or not? Versus in case two, they're much more condensed, and there does appear to be a difference between the different classes. So we need some theory for this test. The statistic we're going to use is an F statistic. I'm not going to give a formula here, but the basic idea is you look between sample variability and you divide that by the variability within the sample. So a big one here means there's more between sample variability than there is within the sample. So this is an F statistic. The requirements to form this test, you have to have K simple random samples, one from K different populations. They have to be independent of each other, so they can't be paired or grouped or anything. And then the populations here have to be normally distributed, and they have to all have the same variance. Now, for these last two here, this procedure is pretty robust, meaning you can have some slight deviations from a normal distribution, and the variances don't have to be identical. We'll talk more about this later on when we look at an example. Let's think about our current life rating example and look at those four criteria. First of all, they're K simple random samples from K different populations. So each of those three K populations, the yes more than once, yes once, and no, they're different populations. Okay, so second one, they have to be independent of each other, right? So they're totally different individuals. These individuals were randomly selected to participate in this survey, so that is definitely true. Now, the populations have to be normally distributed. We have pretty large sample sizes here, so we can use histograms to see this. So let's take a look at those three histograms. And you can see here, if we put a normal curve, the first one looks pretty good. It's a little skewed left. The other two are a little blocky, but they're relatively normally distributed. So this one is reasonable enough. They're not terribly skewed. So we're going to say this condition has been met. The last one, they have to have the same variance. So I used StatCrunch to find the variance, and I grouped by suicide. And you can see here, they're not all the same. So a good guidance here is to find the variance ratio of the largest variance over the smallest variance, and you don't want that to be more than 2. In this case, you can see we have 3.4 over 2.7, definitely less than 2. So we're going to say that that's okay, and this test should work. We're going to say that's okay, and this test should work then. We should be able to do an ANOVA test. So let's dive in and try this hypothesis test. You know the steps by now. Our null hypothesis here is that the mean is the same for all the groups. In this case, it's the mean life rating should be the same whether the individual has attempted suicide and all the different responses they could have there. The alternative is just that at least one of the means is different. Doesn't mean they're all different from each other, but the null hypothesis is that they're all the same. Well, then the alternative is that at least one is different. Our alpha, we use our same alpha as always, 0.05. The test statistic, we're going to use StatCrunch to find this F between sample variability divided by the within sample variability. So in StatCrunch, this is stat, one-way ANOVA with data. And we're looking where all our variables are actually in the same column, and it's the life now. And then the groupings are in the suicide column, so we'll choose that. And then we just hit compute. And that gets our F statistic of 53.04. The p-value here, very small, less than 0.0001. We could have kind of seen that on the box plots. They looked pretty different. So it's not a surprise that the p-value is very, very small. That tells us we should decide to reject the null hypothesis. And for our conclusion, we would say, yes, there is enough evidence at the 0.05 level of significance to support our claim that the mean life rating is not the same for all levels of responses to that ever attempting suicide question. Now, just to reinforce this, I did some confidence intervals. So I have these confidence intervals from StatCrunch. And if we look at those and kind of round them, we get 6.5 to 6.7 happiness rating for those who said no, 5.7 to 6.1 for those who said yes once, and then 4.7 to 5.4 for those who said yes more than once. If we clean those up, they look like this. Let's visualize them and make a scale. So we'll have a scale here from 4 to 7. And let's look at some confidence intervals. And here we can see that, in fact, all of these confidence intervals are separate. None of them overlap. So every group appears to have a statistically significantly different mean from the other groups. That just reinforces our ANOVA that, yes, at least one of the means is different from the others. In fact, they all look different from each other. That will not always be the case, but that appears to be the case here. Let's do another example. In our Children of Immigrants database, I'll put that link in the description, we have a variable called the socioeconomic status. That's a measurement of income and wealth. Now we might wonder, what are some variables that might predict a difference in how an individual ends up in their socioeconomic status? I thought it might be interesting to look at the parents' education. So we have father's education and mother's, so I chose mother's education. So what I did is, let's make a box plot of SES by mother's education. So we'll go to graph box plot, and we'll choose SES, and then we're going to group by mother's education. I'm not going to do all the titles and stuff for this analysis, but you can see here, there appear to be a difference. Let's dive in a little bit deeper, and we have to check before we do the ANOVA if we meet our criteria. The next thing we need to check then is, are all of the populations normally distributed? So let's do a histogram. So we'll do graph histogram of SES and group by mother's education, and then take a look at those. And then right off the bat here, it starts off bad. The elementary one is very skewed right, so that's not good. But for the rest of them, they actually look okay. They're pretty symmetric. In fact, the more education you get, the more symmetric it gets. I think a big part of that is sample size. There are more individuals in those higher education categories. So what we're going to have to do here is we're going to have to leave out those whose mother's education was elementary school or less. We're just going to have to exclude those because that population is not normally distributed. We do also need to check that the variances are all the same or not markedly different. So we'll go to Stat, Summary Stats, Columns, and we'll choose our SES and then group by mother's education. And you can see all these variances. Remember, we're worried about the largest one being more than double the smallest one. And they are all fairly similar here. So we should be good. We should be fair to assume that the variances are all the same. So let's try the hypothesis test then. Our null hypothesis is that the mean SES, the average socioeconomic status, is the same for all levels of mother's education. And then the alternative claim would be that at least one of the means is not equal to the others. Alpha, our level of significance, we'll use our 0.05, compute the test statistic. This is our between sample variability over our within sample variability. And let's use StatCrunch to do that. Again, that's stat, one-way ANOVA with data. And again, for ours, our variables are all in the same column. So we're going to use SES. And then the factors are in the mother's education. And we'll hit compute, and we get our results. So our F statistic, very large, about 976. P-value, very small, less than 0.0001. When we make our decision then, it's easy. We'll reject the null hypothesis. And so our conclusion is, yes, there is enough evidence at the 0.05 level of significance to support the claim that the mean socioeconomic status is not the same for all levels of mother's education. And again, that reinforces what we saw on that box plot. It looks pretty clear here that as education level increases, that socioeconomic status increases as well, which makes sense. The more educated your mother is, the more likely you are to be educated and pursue higher education as well. But it's pretty clear, to me, it's kind of startling how almost linear this relationship is. Even at the lower levels, middle school or some high school, every little bit of education for the mother makes a difference in the child's education. This is fascinating. Now keep in mind, this is just in the Children of Immigrants database. So maybe this relationship is more pronounced for immigrants. We don't really know here. But it is very pronounced, certainly for this population. So just to bring it all full circle, this is one-way analysis of variance, ANOVA. This is what we use to compare multiple means, more than two means. That's what ANOVA is for. We have these criteria here, and there is some flexibility in those last two, but your populations have to be normally distributed, and you can use histograms to check that, or if you have small sample sizes, you can do a QQ plot. And then for that last one there, your variances should all be the same, or your largest one shouldn't be more than double your smallest one. Okay, wow, we made it. That is the last video. Congratulations, you made it. I would say if you like this, subscribe, hit the bell for more, but there are not going to be any more statistics videos. This is my last one. You can certainly, if you like this, subscribe to my channel. I'll be coming out with more videos periodically, but I'm so appreciative of you for watching. And I always want to thank the Elgin Community College Board of Trustees. They're the ones that approved my sabbatical for the spring of 2021 semester. And that was the only way that I had the time to record all of these, research all of these, find good examples, find data for you, and I really appreciate it. So thank you so much for watching. If you've watched this whole series, well, you might be one of my students and you had to. If you are not one of my students, I really appreciate you as well. Thank you so much, and I will see you in another video.